Imagine a place of stark beauty, a realm of ice and snow that shimmers under the ethereal glow of the aurora borealis. This is the Arctic, Earth's northernmost region, a vast expanse of ocean covered in a constantly shifting cap of sea ice, surrounded by frozen tundra and glaciers. The Arctic may seem like a distant and desolate world, but it plays a crucial role in the Earth's climate system. The icy expanse reflects sunlight back into space, helping to regulate global temperatures. It's also home to a unique ecosystem with polar bears, walruses, and seals adapted to survive in this unforgiving environment. Understanding the Arctic, its delicate balance, and the forces that shape it is essential for understanding our planet's climate as a whole. One of the most significant of these atmospheric phenomena is the polar vortex, a powerful force that plays a key role in shaping weather patterns across the northern hemisphere. High above the Arctic, in the stratosphere, a swirling mass of cold air circles the pole. This is the polar vortex, a persistent area of low pressure that acts as a giant refrigerator, trapping frigid air within its swirling embrace. Imagine a spinning top, its axis aligned with the Earth's poles, its top and bottom flattened out by the Earth's rotation. The polar vortex is not a single monolithic entity. It's more like a rope, often contorting and stretching, at times even splitting into two or more smaller vortices. These fluctuations in its shape and strength are influenced by a complex interplay of atmospheric factors, including solar radiation, the distribution of land masses and oceans, and the jet stream. When the polar vortex weakens or shifts, it can unleash frigid Arctic air southward, bringing bone-chilling temperatures and winter storms to lower latitudes. The polar vortex, despite its image as a harbinger of extreme cold, actually plays a crucial role in maintaining the relative warmth of our planet. By trapping frigid air within its swirling embrace, it prevents the constant southward flow of Arctic air masses, allowing for the development of more temperate climates at lower latitudes. The strength and stability of the polar vortex are influenced by a complex interplay of factors, including the amount of solar radiation reaching the Arctic and the dynamics of the jet stream. When the polar vortex is strong, it acts like a well-defined wall, keeping the coldest air bottled up in the Arctic. However, when it weakens, it can become wavier, allowing frigid air to escape southward and warmer air to penetrate northward. These fluctuations can lead to extreme weather events, such as prolonged cold snaps, heavy snowfall, and even heat waves in unusual locations. The term polar vortex has become increasingly commonplace in recent years, often associated with news reports of record-breaking cold and heavy snowfall. While the polar vortex is always present in the stratosphere, certain atmospheric conditions can cause it to weaken and stretch, allowing lobes of frigid Arctic air to break free and plunge southward. One of the most well-known examples of a polar vortex outbreak occurred in January 2019, when a large portion of the central and eastern United States experienced record-breaking low temperatures. Cities like Chicago and Minneapolis saw temperatures plummet to dangerous levels, with wind chills making it feel like minus 50 degrees Fahrenheit. While polar vortex outbreaks are often associated with extreme cold, they can also contribute to other types of extreme weather events. Understanding the dynamics of the polar vortex is crucial for predicting and preparing for these increasingly common extreme weather events. The Arctic is warming at an alarming rate, more than twice as fast as the global average. This rapid warming is melting sea ice at an unprecedented pace, shrinking the reflective surface that helps regulate global temperatures and contributing to rising sea levels. The warming Arctic is also having a profound impact on the polar vortex, altering its strength and behavior in ways that are still not fully understood. Some scientists believe that the warming Arctic is weakening the polar vortex, making it more prone to stretching and wobbling, leading to more frequent and extreme outbreaks of cold air southward. Others suggest that the link between climate change and the polar vortex is more complex, with some studies indicating that a warming Arctic could actually lead to a stronger, more stable polar vortex. Regardless of the specific mechanisms, it's clear that climate change is having a significant impact on the Arctic and its influence on global weather patterns. As sea ice melts, it exposes darker ocean water, which absorbs more heat from the sun, further amplifying the warming effect. The thawing of permafrost, permanently frozen ground found in the Arctic, is releasing methane, a potent greenhouse gas, into the atmosphere, further contributing to global warming. The polar vortex, despite its seemingly remote location, plays a crucial role in shaping our weather and climate. Understanding its behavior, its interactions with other atmospheric phenomena, and its sensitivity to climate change is essential for predicting and preparing for extreme weather events. Scientists are using a variety of tools to study the polar vortex, including satellites, weather balloons, and computer models. By gathering data on temperature, wind speed, and atmospheric pressure at various altitudes, researchers can track the movements of the polar vortex and develop more accurate weather forecasts. Understanding the polar vortex is not just an academic exercise, it has real-world implications for agriculture, transportation, energy production, and human health. The polar vortex is a powerful reminder of the interconnectedness of our planet's climate system. While it may seem like a distant phenomenon, confined to the frigid reaches of the Arctic, its influence is felt across the globe, shaping weather patterns and influencing extreme events. As we continue to grapple with the challenges of climate change, understanding the polar vortex and its role in global weather patterns will become increasingly important. By studying its behavior and its sensitivity to a warming climate, we can improve our ability to predict and prepare for extreme weather events. The journey of discovery is never-ending, and the pursuit of knowledge, like the swirling dance of the polar vortex, is a testament to the boundless wonders of our universe.